Okay, we're all live.
All right.
Let's see here.
So, says, make sure, okay, I'm done that. Ensure that each team member understands how to identify each transformation, stretch, shrink, Y value is reflected over the x-axis, horizontal shifting and vertical shifting. Make sure that the graphs from the preparation assignment match. And then go over the inverse functions worksheet. Okay. So why don't we do that right now? Go over the what you want to call it?
Can you guys see that at all?
Oh yeah, look at that.
Yes.
So
Yeah.
Minimize this. Just give me 2 seconds here. There we go. That's basically the instructions there. And we also have that group quiz to do, so.
Oh yeah, that too. Yeah, we'll do that after.
Perfect. So let me, do you want to go, we need to pull up my first problem so we can kind of look at that real quick.
Sure, let's do that.
Okay, let me pull this over. Hang on, I got to pull this one out real quick. There we go. Can you guys see that all right?
Yeah.
Make it a little bit bigger. So again, I haven't finished this one. I was kind of doing the same thing that they did on the exploring inverse functions, like the prep assignment we had to do before we did this meeting, where it has x values of 0, 1, 2, 3, and 4. And so I was just kind of going through here. And again, I haven't done number 4 yet. And so I can erase that actually. But so I just have like the equation here, implemented 0 in for x, and I got negative 197. And I just went down. I haven't graphed it yet again, so I just kind of started on it.
All right.
So. If we want, we can kind of go through number 4 if you'd like. We can just go through one of them together, at least, and can do the practice quiz as well here in a bit.
Sure.
So I was putting, as you can see, -3. Oh, why are you? I don't want you highlighted. Hey, now. Well, this is how I was doing. I was copying, pasting, and then just changing my answers around here. So then I'd put this one as 4.
4, yeah.
And then over here, 4 minus 4 is 0, which doesn't need to have the negative there. 0 cubed equals, of course, 0. And then -3 times 0 equals, of course, 0.
Yeah.
Plus 5 equals 5. Okay. I don't know if I'm doing that correctly or not, but that's at least how I was doing it. So.
Looks pretty good to me.
All right, perfect.
Yeah, looks fine to me.
Perfect. So, yes.
Do we need to, would it change the answer if we had to expand that out like we did with that last, on Tuesday? Would that change?
How we had to do like the FHX type of thing?
Yeah.
I don't know if that would change or not, or if you're supposed to do that or not. I was just curious about it.
Yeah, I don't know the rule behind that very well. I guess we can try to expand it out. Let's try it.
Personally, I think that's only when you have variables. but it's just me.
Oh yeah, yeah, that's what I think too. Because you can just add it out.
Oh,
When you have
Yeah.
another,
like that. X or H.
yeah. If you had like an H there or a G,
Gotcha. Yeah, that makes sense. All right.
there we go. That works. So, Chris, do you want to try resharing your screen so we can go over problem 2, possibly again?
Yes. Let's just
See if
a
it'll
second.
work again. I don't know how to stop screen sharing. There we go.
Okay.
If it looks weird that I'm not ever looking at my camera right here, it's because I have a big monitor up top that I'm looking at. So,
Second. Open your document. And then okay. Let me try that. I don't know if it'll be trippy again or not.
I like good old screenception.
There we go.
That worked?
Yep.
Yep.
Let me just
There we go.
change that.
Sort of ish.
Ah. And then that. There we go. Put that over there. Put that over there. Make that bigger. Okay. Perfect. So it says graph the following functions by identifying the transformations, domain, and the range. Okay. Let me set up a graph here. Okay. So we know that inside the parentheses, it moves the graph either to the left or the right. And because it's inside the parentheses, you do the opposite. So we need to move left 2. At the end, the last thing, it's up or down, and you do exactly what it says. So you need to go down 2. And let's see. Oh yeah, and you have to double it because I think it's squared. Let me check. Yeah, it's squared. Actually, can anybody help me about that? I was really confused on how exactly you go about doubling it when it's squared.
What is it?
Well, squared just means that it's a parabola going into positive parabola.
Oh, right, that's right. And so when it's a negative, it's facing downwards. That's right.
Down, yeah.
Right. Thanks.
So with the positive 2, that means it starts at 2 on the y-axis
Mm-hmm.
and goes up both sides.
Let me find. Okay, there we go. Okay. So you left 2 and down 2. I'm not mistaken.
I think you go left 2 and down 1.
Oh, down 1. You're right. Thanks. Nope, that's not the one. There we go. a little bit of a ski-wampus parabola, but
I'm impressed you found something that looked even similar to it, to be honest.
Mhm.
I know, I like have no idea what you've been doing this whole time, and I thought they looked kind of funny until now.
okay. So shrink that down. Okay, so that's like our makeshift parabola, if you will.
That works.
We want it to go left 2 and down 1. About like that?
That looks right. In theory, the right part of the skewer would go past the x-axis, but it doesn't have to be perfect.
Yeah. Yep. But in theory, that's there we go. That's about it.
Mhm.
Okay. Let me edit this because that's a little odd looking. Okay. Let me check to make sure that's the correct one.
And for the range for number 1,
Right. That's what I was missing, yeah.
range. And when I was having such a hard time with domain and range until like I started graphing everything, and then it just gets so clear.
And I think it's option 5. Yes, it is. So I think that this is that's that. For this one, it looks like to me, we include -1, go up to infinity for the range. How does that look?
Yeah, that looks about right to me.
That's good.
All right. Let's go on to number 2, or wait a minute. Yeah, right, this one. Radical X. So I think here, just check. Yeah, okay. So normally, that is range, rotate. Normally that's about right, like that. Normally, but since we have a -x, that tells us we have to flip it, get back the other way. And we have to move left to -3.
So where are you guys finding these particular problems at?
Let me
Separation.
Yeah, so right before the oh shoot. So in week 2,
Yes.
functions. Do it up here actually. So assignments. No, I didn't want that actually. Just kidding. Content, week 2. And this is lesson 1 and 2. So we scroll down until we get to lesson 3 and 4, right there. And so here's this Google Hangout. And this is the resources to help you. And right here.
Oh,
3 and
gotcha.
4 preparation.
Preparation, gotcha.
Yes. And so here will be the assignments that we do during it. And here is the quiz we'll do after.
Okay, perfect.
For now, we're in here. Okay. Where was okay? We're all the way back here. Where did I put it? I thought I was going to go trippy again. Okay. So we know that we just flipped it. And then because it's inside the parentheses, we do the opposite. So we have to go left 3 spaces. That's going to be about... No, it doesn't want to fit on the screen. Shrink it down a bit. Come on. Oh boy. Why do you not want to do that? Okay, there it wants to do it. Okay, so it should be about there. Nope, didn't want to do it. Don't ask me why. If I move this over here. Man, from I don't know. Okay. New page. Put that right there where it was. Just kidding. Right there where it was. And that should be, okay, that's about what it is, except it should be over there. Right there. Does that look about right?
So because it's a negative square root, I don't think that it's supposed to, it's mirrored. I think that it's mirrored over the x-axis. So we had it facing the right direction. It just needs to be like,
Because yeah, you have your negative on the outside of the square root, right?
yeah. Yeah, so it basically needs to be the exact opposite of what it is right there.
Oh, so this actually be right there. There. I wrote that down wrong. That explains it. Okay.
There we go.
Let me check that. Oh, yeah. Yeah. Now I see what you're saying about that. Shape format. We'll do a little rotation.
Yeah.
Okay.
There you go.
That makes a little bit more sense. Okay, so originally it was like this.
Yeah, and that's just square root x plus 3.
And then you moved over 3, and because the negative's on the outside of the radical, you flip it, reflect it about the x-axis.
Yeah.
That makes sense. Okay, let's do the domain and range. So the domain to me looks like we include -3 all the way out to infinity.
So is domain on the y-axis or is domain on the x-axis?
It's the x-axis.
Okay.
And so it's a little square bracket because we include the -3.
Right.
It looks like for the y, I think this is the case, but I'm not sure. Maybe it's this. I think it's this.
Sad face.
That face. -infinity to 0 square bracket. I think that'd be the case because we go out to infinity and start at 0. Does that make sense?
Yeah.
Right. Okay. What else did we have to do for that? Okay. Let f of x be the function f of x squared x minus 2 cubed plus 3 and fill out the following table and sketch the graph of the function. All right. That. Maybe not. Actually, let's do a new document. That'll probably be a better idea.
Yeah.
And we want to park that down. That was there, and we want to bring this back over there. Okay, now there we go. And we want to blow that up. Okay. So we have the points. F of x. Oops. There's something. Minus 2. 3 plus 3. We have that 5 times.
That's cubed, not 3 plus 3.
That was cubed. Oh, thanks for catching that. One, 2, 3, 4, 5. We have 0, 1, 2, 2, 3, and 4. So I think since there are 5 people.
So is this the quiz?
No, this is not the quiz. This is still the preparation.
Oh, this is still the prep. Okay.
Yeah.
I've already printed off the quiz. The quiz isn't too long. It's only got 2 questions on it.
Okay. So I think since there are 5 people, I think we may be able to assign 5 people. So, and then we can each do one individually and then report back, so to speak. So I'll put the names of each of us. I'll do that one. That font. And then James, if you could do the next one, that'd be great.
Which one's the next one?
It's the f of x 1
One.
minus 2 cubed.
1 times -2 to the third plus 3.
Uh-huh. And Jerem, if you could do that in the next one after that. So instead of Jason, if you could do the next one.
So I'm doing 3 minus 2 cubed.
Yes, that one. And then Taylor, if you could do the last one.
Perfect.
Great.
So you just want us to solve it?
Solve it and report back. Yeah.
Okay.
All right. Well, mine's 4, I think. 'Cause 3 minus 2 is 1 cubed, just 1, and then plus 3 is 4.
Actually, let me check. I don't know exactly what she wants us to do with that. So, oh, yeah. Solve it. Okay, so the first one should be 3. So mine will be 3.
Mine will be 2.
Where did I put the other one? Okay. Let me make a little diagram so we can get that in there. You want it to be 2 by 1, 2, 3, 6.
5, 6.
Ah, dang it. Okay. I want that to be X and that to be Y. I want this to be 0. That to be 1, that to be 2, that to be 3. Oops. This to be 3 and that to be 4. Okay. Now we should be able to do this. Relative amount of ease. Okay, so mine's just going to be 3 because. And then James, what did you say yours was?
I did mine wrong. So no, I didn't. It's 2.
It's 2.
Yeah.
And then Jerem, what did you find yours to be?
So when cubing, it's -4 times for mine. It would be -4 times -4 times -4. That's -64 plus 3, -61.
61.
Does that sound right? -61.
-61. Yeah, because it's a cube root, so it'd be negative. Yeah.
All right.
And then Jason.
So mine would be 1 cubed, which is 1, so mine's 4.
4. And then Taylor.
I got mine as 11.
Let me just check with a graphing calculator real quick to make sure everything's on there.
61. That's the 2 minus 2 cubed plus 3, right?
Yeah, so that'll
just be 3.
that would just be 3 because 2 minus 2 is 1.
Or 0.
0 cubed plus 3 equals 3.
Right. So that's not multiplying, that's subtracting.
That's subtracting.
All right.
Maybe.
I was confused about that too. So all we did was put in.
Let me just get rid of that.
We just put in 1 through 4 in for x, and so it was just whatever x minus 2 was.
All right. So it's okay.
Sorry about the confusion.
This was like. Okay. Yeah, I see it. So that's just 3.
For number 2. Yeah.
Yep.
I think the first one's 1, isn't it? For 0. 0 minus 2. Oh, just kidding. Well,
2.
0 minus 2 would be -2 cubed.
Oh. Did I do that wrong? Yeah, I did.
Yeah, so that one should be -5.
Yeah.
-2 is 4 times -8, and then -8.
It should be -5. Yeah, you're right. Let me just check. Oops.
That was 2.
The next one should be 2, and then that one's 3.
4 and then 11, correct?
Yeah, I'm just checking.
Yeah.
Yeah, it looks like so far so good. Okay. And then we're supposed to be able to graph the function. Not too hard. Pull this from the other one. Actually, I'll need that, so I'll leave that there. Okay, so since we know it's cubed, it's going to be something like this. Make that bigger. Okay, that's what it'd be normally. And then so we have to move it to the right 2 and up 3. 1, 2, 3. Just like that.
Perfect.
Okay. So we want to find the inverse, which is easy enough. We just have to swap the points around.
Yeah, so I just change your x and your y so you don't have to go through and swap everything.
Oh, that works too. Y, and that's the x. Done. And then plot these points on the graph. Okay. So, oh yeah, we'll need another one of these. -5. 1, 2, 3, 4, 5. And that up 1, 2, 3, 2. So kind of like that, I think. Maybe not. No, that doesn't seem right.
So if you do the inverse function, then it's basically the equation x plus 2 cubed minus 3, correct? And would you go down 2 and then down 3? Or left 2 and down for it?
Yes. Which one? Okay, yeah. So it'd be left 2 and then down 3. So yeah, about that. Kind of like that.
Correct, anyway, if I've got my inversion correctly.
That makes sense.
Well, you can use your x and y points to make sure that it is lining up.
That's about what it should be.
So, you know.
Mm-hmm. Okay, so yeah, there's clearly some similarities. Just a bunch of shifting. And the points are swapped. Okay, notice that to find the inverse function, you switch the x and the y's values for both the data and the graph. Use the same method. Okay, yeah. So then you were taking this new equation here and then doing something similar.
That's the same equation.
Oh, yeah. Duh. Yeah, that's what you just explained to me. Duh.
Yeah.
Duh. Does every function have an inverse function? Can you think of a function that might not have an inverse function? That is true. Not all functions have an inverse function. I'm trying to think of one that doesn't have an inverse function.
What does it mean by have an inverse function? Because all functions can be put negatively.
Sure, but then the problem is that I think to have an inverse function, every x has to have a unique y, and that doesn't work for some functions. Like I believe a cardioid possibly does not have an inverse function, but
A what?
a cardioid.
What's your major?
Food science. No, I took this class before, and I'm just retaking it because I didn't get a good grade on the final.
Oh.
I think a cardioid does not have an inverse function, but I'm not mistaken. Not. No. Yeah, so that's what a cardioid looks like.
Holy crap!
Good night.
Are we gonna learn about that?
Yeah, you're gonna have to learn how to draw these. But
It looks mildly inappropriate to draw to me.
but anyway, yeah. So I think those don't have inverse functions because you can see that doesn't. Oh yeah. Let me put it a lot simpler. The vertical line test, if it does not pass the vertical line test, does not have an inverse function. So this clearly, on several accounts, does not pass the vertical line test. So a circle would be the same. A sideways parabola would be the same.
Sometimes the x cubed or the something cubed function, like the one that we have, in certain situations that wouldn't have an inverse function either. Because if you have the part where it slows down, you can actually have it kind of go up and then back down the same way, and it crosses over multiple numbers on the x-axis. If that makes
sense. Yes. So there's a lot of scenarios where that would not be the case. So I think. Okay, so I think we're done with the prep, so that's good.
I think all that's left is the quiz, isn't it?
No, we have to do I think we have to do one more thing.
The
Extension problems,
You ready to
exactly.
do those yet?
No.
All right. Yeah.
So I didn't think we had to go over the prep, but it said in the instructions for today that yes, we do in fact need to go over the prep. So
Which
I guess
helps because the first extension looks like one of the prep problems.
it should be similar. Yeah, it's similar enough. Do a little fancy work here. Command A, delete everything at once. Okay. So here we have this problem, this formatted text. Big. Almost there. We'll get through this. Okay. So this is what we have to graph today.
And remember that x minus 4 is cubed, not 3 plus 5.
Thanks. I don't know why it does that, but it tends to like to do that for some reason.
Good.
On the graph here. Okay, we know we have an x cubed graph from our parent functions. Let's see if I can pull this one again from over here. Okay, so that's what it is normally. And we know that inside here is a -4. So we have to move it to the right 4. About that. And then we have to move it up 5. That's about what it should be. And then this -3. If I'm not mistaken, that triples everything. Or in this case, divides everything by 3. Let me check to make sure that's the case. Oops. Yeah. Oops. Okay. Yeah. That's right. That's right. Okay. So you want to do something? Yeah, you don't want to do that. Just make it. Why is that? And then flip it because of the negative. That look about right?
Yeah.
Yes.
So yeah, shrink it down by 3 and then flip it because it's a negative. And looks like that should be it for that. And then want to do this something similar. This. Okay. I want to. Okay. Okay. Actually, I think I might have done that already. Yeah, I did. Okay. So to do this one, we first start by swapping the x and the y. So that's just the original problem. So it'll be x equals y plus 2 divided by y minus 3. And then we want to multiply each side by y minus 3. As you can note right there. So you got rid of that, moved it over. So that would result in xy from that and 3x from that. And that should equal plus 2. And oops, plus y. And you want to subtract the y and get it on that side. I try to, isolate it and get the 3x back over here. So I'd make xy minus y because you put the y over here and then the 2 over here. And you added this back over here, so it's 3x plus 2. And then don't know why that's x minus 1 now. I can't remember why that's x minus 1. Why would it be x minus 1?
Because you divided y out of everything.
Right, I factored y over. That's right, thanks. Yeah, because I put the y in front and then took the y out of both of these. And then got y by itself. So it ended up being 3x plus 2 and x minus 1. Does that make sense to everybody?
Yep.
Yeah, I'll go with it.
Okay, let's check the answer key. Yeah, so that's about what we had for that. And the domain and range was everything, which makes sense. And then this is what we have. Yep, so that looks good. Okay, last item on the agenda for today is the group quiz. And we will stack that.
And then only one copy of this group quiz is
Submitted.
Mm-hmm.
Right here, yep. Okie dokie. Group quiz. Answer the following questions as a group, and the group leader will submit one copy for the group. Make sure to submit the group quiz as a single PDF document. You may only use your textbook, notes, and a calculator on these problems. You may not use any outside resources, including the internet, tutors, or solution manuals. Remember that the purpose of this quiz is to see if you understand what you have learned on your homework, and also to tell you what you still need to study for the upcoming exam. Make sure to show your work and to be neat and organized. A correct answer without supporting work will not receive full credit. Simple enough. Number 1, write the piecewise function for the following figure below. You should identify the domain that corresponds with each equation. Okay. Let me format that. F of x, and then insert. Actually, just kidding. Okay, sorry about that. Okay. Okay, and then we want the graph as well. And we have 3.
Doesn't like that idea.
No, it really doesn't.
Are you just trying to recreate the graph in the?
Yeah. Either way.
Can you not just
That
copy
photo.
and paste it in?
Can you
Can
repeat
you
that?
not copy the image and then paste the image from the website?
That's actually not a bad idea.
If that doesn't work, you can just drag and drop it in Microsoft Word.
A special. Download it. Okay, I'll have to download it. That's fine. Open. Oh, yeah. Shift Command 4. So it looks like I'll have to do a screen grab to get it to go. But it will finally go. Nope.
Are you using a trackpad on your? You can always just drag that photo that's on your desktop and like drag and drop it. Oh, there it goes.
Yeah, that's what I usually do, but for some odd reason. I have a better idea. Layout, margins, no. Landscape. Yes. Yes. That way I can put a text box on top of the image itself. No.
Sorry if you guys are hearing something that sounds like a train. It's because I live right beside train tracks.
Because it is.
It kind of sucks because this happens at like 2 and 3 a.m. sometimes.
It's okay. I used to have a train horn on my car, so I sounded like a train.
And I just drive at 2 miles an hour purposely down the road. I've called the cops on this train before.
Have you really?
It was blocking the road for like 45 minutes. They have the idea that they can just like cross a road and then just stop and chill for like a half hour.
That's hilarious.
And of course, it's against the law to block the road for more than 5 minutes. And such, so that was fun.
How are they going to move it? How many ton train off the road?
Well, I don't know what they do. So, like, I don't know. They have like the train track, and then they have the road that kind of does a U on the train track. So the train crosses twice. And so instead of like pulling all the way in and then just putting the lead car in the front, what they'll do is they'll like pull in one way and then they'll back in so that they don't have to turn anything around and they're already good to go. And so to do that, they just like hog the road for like 20 minutes at a time.
Yeah.
Sorry, it's kind of off topic.
Yeah, that was off topic.
There's a little commercial break.
Yep.
For the teacher.
Yeah, I didn't get the chance to introduce myself to you guys in the first group, so that was me.
Oh, good.
There you go.
Yeah, I guess you're the guy that calls the cops on trains.
I've also had to call the cops on a nightclub, but that's a different story for a different group activity.
For another commercial? Okay.
Yeah.
Okay. So we have to find the graph for each one of these piecewise functions. And state the domain for all three of them. Okay, so let's start with this first one here. I'll shrink down that font because obviously it's not going to fit in there, all three of them.
And are we just putting them in y inner slope form? Like,
yeah, I think so. Yeah,
y
slip in.
x plus b?
Slip it, yes, slip intercept.
Yeah, slip intercept, that's right.
Okay, so what we want to do is, okay, so for this first line, we have these 2 points. So we can do y2 minus y1, which is 0. And we can divide that by x2, which is 0. And subtract that from that. So add it, essentially. We get us our slope.
1.
Is 1. Oh, it's 2. Yeah. So it's 1 divided by 1, which is 1. Right.
Just
Okay. So we have y equals 1x. And so we don't know the slope. We don't know what b is. So we can plug in a point for that. I'm going to use the top one right here for that. So that would be 1 equals 0 plus b. If you plug in 0 for...
If they have the y-intercept as 0, 1 already, you can plug that in as b. You got your equation.
Oh, you're right. To be 1.
So x plus 1
X plus 1.
from negative infinity to 0.
From negative infinity. Yeah, right. Negative option 5 to... Would that be positive? We're doing x's.
0, right?
To 0, yeah, it's 0.
Yeah.
Good call. And then, so that would be number 1. Supposed to keep organized here. Also number 1. Oops. And so this will be number 2. Oops. Also, mark which ones we're claiming to be 1. Since she will know. That. Have that. Okay. Like that. Three. At 2. Oops. At 3. And at 2, and that's 3. Oops. Okay. Got it. Okay. And then this would end as y equals x plus 1. I like that because we found it as the answer. Okay. So round 2. y2 is negative 2. And y1 is 1. So minus 1 divided by x2, which is 1.
Looks like it's
Minus,
-3 as the slope.
and that would equal... Oh,
It's -3 divided by 1, so -3, right?
yeah. Just wanted it to be organized. Not that I don't trust the answer's correct.
Right.
Just wanted...
No, you're good because you have to show your work anyway. Otherwise, we won't be able to get credit for it. So
Yeah. So we have a negative 3x plus something plus b.
Plus
So-
your y-intercept, which
Oops.
is the
Yeah. So we'll plug in the first one up. The y-intercept would be 1, wouldn't it? again because
I think
Our-
so.
it's already shown on the deal. Shown on the graph.
Yeah.
So that equals negative 3x plus 1. And the domain is between 0 and 2, negative 2.
Yeah.
Well, is there an arrow pointing anyway?
No,
Or is
because
it
it
just
goes
that line?
back.
1. Just kidding. It's 0 to 1.
Yeah. Okay.
Because it goes from here, x 0 being 0, to here, x being
I
0,
got you. Yeah.
and 1. Yeah.
That makes sense. Okay.
And round 3. Oh yeah, okay. So y2 is 2. And we want to subtract that from y1, which is negative 2. So we're going to add 2. And we're going to divide that by x2, which is 3, minus 1. Oops. That should equal 4 divided by 2, which equals 2. So that would tell us that y equals 2x plus b. We're going to use 3, 2 as our point to find the y-intercept. So that becomes 2 times 3. Oops. Plus b. So we want 2 minus 6, which happens to be 4.
-4.
Negative 4, correct, you're right. So we have for our final answer,
Yeah.
y equals 2x plus 4. Negative 4, minus 4.
4.
Thank you.
Yeah. That's 1, 3. Domain.
Oh, come on. Okay, I got it. So we have a 2x minus 4. And for the domain, it should be 1, 1, 3. Yeah.
Yep.
1, 3. Oops. So that should be it for that problem. For the following equation, f of x equals negative 5 minus 2x minus 3 cubed. It shouldn't be too hard. I hope. And that's a cubed. And then we want to copy that as well. Identify. Okay. Identify the all transformations. So let's see here. We have a right 3. And let's see, what else do we have?
You'd have down 5.
Down 5. That's right.
And then you'd also have a stretch up 2, I believe. Is that right?
Yeah, stretch.
Stretch of half versus a stretch of 2.
No, because it's negative.
Yeah, but you have stretch 2 and then it inverses or it flips, whatever it's called, because of that negative, right?
Yeah, I think too. Yeah, and then an inverse. I think that's
The inverse or the mirror, or how would you say that? I don't even know.
Wouldn't you say it flips over an axis? Isn't that?
reflects about
Yeah, this one says reflects over x-axis. I just looked at the one that we did before.
the.
They say reflect over x-axis.
That looks good to me. Okay. Why did I not want to do that? Okay, we want the domain. Yeah, let's graph this because it's going to be darn near impossible to deduce what the domain range would be without. I mean, you could, but it's going to be so much easier if we graph this. Okay, let me try to pull this. Ah. Format. Oh yeah, it's already inversed. So we want to move it right 3. 1, 2, 3. Down 5.
And by 2, it's just elongated a bit.
Yeah, that's what it's supposed to be. Anyway. So I think we're safe to say that the domain is
Native
infinity to
Infinity.
Yeah, that should be the range and the.
yeah. Option 5. Option 5. And you want the range. Native infinity. Domain range determine whether the function belongs to what? Oh, which function the family belongs to. Oh, it says graph the function. We already did that. Function family. Wouldn't it be? I'm guessing it's this. From the parent functions.
Yeah. Yep.
Too hard. And then discuss the symmetry, odd or even.
It's odd, isn't it?
Yes. And then state whether the function is increasing or decreasing.
So
I would say it's decreasing because it has that negative right there.
Yeah, I would agree. I would say just by the idea that as x is going towards positive infinity, y is going towards negative infinity.
So it says state where the function is increasing and decreasing.
Oh, state
So
where, okay.
At where it is.
Oh wow, I totally read that wrong.
So
Sorry.
like -5, -3 is the coordinate, or 3, -5 is where it switches from
Positive to
increasing to decreasing. So above that would be increasing, and below that would be decreasing.
so you're saying it's -3, -5. Yeah.
Or wouldn't it
Yeah.
just be positive
Well,
3,
3,
5?
-5. There
Oh
you
right,
go.
because the opposite in the parentheses.
Yep.
That's right. That's right. That's right. So it's there and there. That's right. And then of course we graph the function right there. So I think that should be it. Let me just save that.
Do we need to specify that last part? State where the function is increasing and decreasing. So 3, -5 would be before
Where
that
it
is.
switches before that would be increasing, and after is decreasing.
Before is increasing and after is decreasing. Okay. So I think that should be it.
Yep, that looks good to me.
Okay.
Good enough for government work.
Not this again.
And it freaked out again.
Yes. Videoception.
So stop screen share. Cancel.
All right.
Okay. So I think that should be it. So thank you all for coming.
Yeah.
And I guess we'll meet next Tuesday.
Perfect. Are you just wanting to submit both of those, the
The quiz and
as well as the quiz?
the video and the quiz, yeah.
Okay.
And then don't forget to put the participation points as well.
And the participation points. Write that right now.
Perfect. Thank you.
Participation, quiz, and the video. Okay. Sweet. Well,
All right.
see you guys
All right.
next time.
We'll see ya.
All right.
Have a good weekend.
Yeah.
Yep.
Bye.
Bye.